It will be an optimization problem. It will be a curve sketch. I think that's it. There won't be a definition of the derivative. There won't be any basic differentiation because that's what we just tested you on. However, of course, you're expected to be able to take derivatives. Okay? So I think that's pretty much what's going to be on it. I wrote the rough draft. Professor Sutherland's now going to go through and do his draft, and then he and I will put our heads together and come up with the final draft. Okay? Okay, after we write the final, which will be, like I said, in the next couple days, we will then put up practice problems for everybody, because I don't want to put up practice problems if they're a waste of your time. This isn't chemistry. I mean, we're going to put up practice problems. There will probably be a couple of Professor Sutherland's old exams, plus I'll write some more practice problems. When is the review session? Monday, 12 to 2, in Javits 100, everybody's favorite room. Okay, nice big review. So I will be there. I will do sample practice problems for the exam. I will be in my office at various times on Monday and Tuesday. I don't know when yet, and when I figure that out, I will post them. Let's see. Okay, there's a problem. All right, let's do this one. All right, we love these that involve the product rule because you guys all forget about the product rule. So let's do this. Derivative of 3x squared is 6x. The derivative of 4xy cubed, you use the product rule. You have two functions. You have 4x and you have y cubed. So it's 4x times the derivative of y cubed, which is 3y squared dy dx, plus derivative of 4x, which is 4y cubed. You know, we were originally going to have these on part 1, but I took them off. We were going to have these. That would have been really entertaining. So, given how we did the first time through, I think we made the right choice. This is 2y dy dx minus 1. If you can do this, you get half the points. Okay? Because now it's algebra. You've already done the calculus. So again, the middle term here is the tricky one. You have to do the product rule. You have 4x times the derivative of y cubed plus y cubed times the derivative of 4x, which is 4. All right, let's simplify this. We got 6x plus 12xy squared dy dx plus 4y cubed equals 2y dy dx minus 1. And remember what we do. Everything with dy dx goes on one side, and everything without dy dx goes on the other side. So let's put all the dy dx's on the left side. You get 12xy squared dy dx minus 2 dy dx equals negative 1 minus 4y cubed minus 6x. Or you could have all of these be positive, and then you have 2 dy dx minus 12xy squared dy dx. Okay, you can do it either way. Now you factor out dy dx times 12xy squared minus 2 Did I lose a y somewhere?
Yeah.
Where did I lose a y? Oh, I lost a y. Thank you. So you guys, I do that shit. That's why God created partial credit. WebAssign would not forgive me. And the last step, you divide. You get minus 1 minus 4y cubed minus 6x over 12x y squared minus 2y, or 1 plus 4y cubed plus 6x over 2y minus 12x y squared. Okay? Either way. How do we do on that one? Madison? Yes, okay. So we got some thumbs up? Alright, let's do another problem. You guys remember continuity?
Yeah.
Let's review continuity for a minute. And differentiability, because they kind of go together. A function is continuous if when you write it, you never have to take the chalk off the board, pencil off the paper. So that means in order for something to be continuous, you have a function, if f of x is continuous at x equals a, then limit when x approaches a from the minus side will equal the limit when x approaches a from the plus side will equal f of a. All right, find the value of a that makes that function continuous at x equals 1. This is not a hard problem. You've just forgotten what to do. Okay, that's why we're doing review. How do you do this? The limit from the left has to equal the limit from the right, and they both have to equal the value of the function at 1. Well, f of 1, you just plug in 1, and you get 6a minus 2. Okay. Now, what is the limit when x approaches 1 from the minus side? When x approaches 1 from the minus side, you plug in 1, and you get 6a minus 2. And when x approaches 1 from the plus side, you get 1 plus 4a plus 3, you get 4 plus 4a. So, in order for this to be continuous, this has to equal this. 6a minus 2 has to equal 4 plus 4a. That's nice, easy algebra. You get 2a equals 6, or a equals 3. That was easy, wasn't it? You just forgot how to do those. Now, what about differentiability? Okay, now find the values of A and B that makes this continuous and that makes this differentiable at x equals 1. So again, now find the value of A and B that makes this function differentiable at x equals 1. So in order to be differentiable, it has to be continuous, and the derivative from the left has to equal the derivative from the right. Okay? Alright, let's do this one. So in order for this to be differentiable at x equals 1, you first must show that it's continuous at x equals 1. So how do we show that it's continuous? What we just did. Essentially, you plug one into the top and one into the bottom and try to make them match. So the limit, when x approaches 1 from the minus side of f of x, is 5a minus 2b plus 4. And the limit, when x approaches 1 from the plus side of f of x, is 3b plus 6a minus 5. So this must equal this. Where should I put that? We'll put it right here. So 5a minus 2b plus 4 has to equal 3b plus 6a minus 5, or we'll put everything over here. A plus 5b has to equal 9. Okay, now we figured out what you need in order for it to be continuous. Now we need it for it to be differentiable. So you take the derivative of this, and you say the upper branch is 10ax minus 2b, and the lower branch is 6bx plus 6a. And they must also match. So when you plug 1 into the top, you get 10a minus 2b. And when you plug 1 into the bottom, you get 6b plus 6a. And they have to be equal. So 4a, did I make this come out well? Yes. 4a has to equal 8b, or a has to be 2b. Now we have two equations. So we get this equation by taking 1 and plugging into the top, and 1 and plugging into the bottom, and setting them equal to each other. We got this equation by taking the derivative of the top and bottom, plugging 1 into the top, and 1 into the bottom, and setting them equal to each other. Now we have a has to be 2b, and a plus 5b has to equal 9. So you can solve these rather easily. A plus 5b equals 9. And a equals 2b. So 2b plus 5b equals 9. 7b is 9. Or b is 9 sevenths. And once you have b is 9 sevenths, a is 18 sevenths. Okay? A related rate problem. A conical tank has a height of 12 meters and a radius of 4 meters. It is filling with water at 36 pi cubic meters per minute. That's a lot of water, by the way. How fast is the height of the water increasing when the water is 8 meters deep. Alright, we have a conical tank. That is a cone. That's not actually a cone. It's a positive cone. That is a cone. Alright. The great thing about a right circular cone is that the radius and the height are always perpendicular to each other. So when this is filling with water, when this fills with water, however much water is in the tank, the ratio of the radius of the water to the height of the water will be the same as the ratio of the radius of the tank to the height of the tank. Okay? Those will be the same because you're getting similar triangles. Okay? So the radius of the tank to the height of the tank is the radius of the water to the height of the water. So we know that the radius divided by the height is always 4 over 12, also known as a third. So the radius will always equal h over 3. You should be able to tell that a third of h and h over 3 are the same thing. This causes you lots of problems on part 1 of the final. A lot of you are doing quotient rule unnecessarily. It's a lot of work and an excellent way to screw up an easy problem. Okay. Now we know how to find the ratio of the radius to the height. The volume of the cone is 1/3 pi r squared h. And we know that the volume of the water is increasing at 36 pi. We want to know what is dH dt when h equals 8. That's the information that we have. So we could take the derivative of this with respect to t and start plugging things in. The problem is we don't have a dr dt. So we want to get rid of r. Well, we know that r is h over 3. So we could take this equation and rewrite it as 1/3 pi h over 3 squared times h, which simplifies to pi h cubed over 27. 3 squared is 9. 9 times 3 is 27. Now, that is the same as pi over 27 h cubed for all of you quotient fans out there. Let's take the derivative. dv dt is pi over 27 times 3h squared h dt. Notice, no quotient rule. Now you just plug in. So you get 36 pi equals pi over 27 times 3 times h squared dh dt, and now you just have to solve the dh dt, which is 36 times 27 divided by 3 times h squared. Which is 81 over 32 meters per minute. Now, if this were an exam question and this were 10 points, oh, I don't know, getting to here is worth 2 or 3 points. Getting to here is worth 2 or 3 points. You can get into here is worth almost all the rest. You really don't care if you can't quite get the right number here at the end. Okay? We'd like you to be able to do arithmetic because you are in calculus, and arithmetic is something that you finished at about 4th grade, but we're not going to penalize you for not being able to do 36 times 27 over 3 times 8 squared. You might mess it up. Do you have to show how you got pi over 27 times h cubed? If you can get there right away, that's fine. The thing is, remember, not every cone has a ratio of 1 to 3. Right? It's only in this particular cone that the radius of the height is 1 to 3. So you need to start with this equation. What if I told you that the radius of the cone is 1 to 2? So you should understand the process, which is you find a ratio of the radius to the height, and then you can use it to get rid of either radius or height, and simplify the equation. Right? I said the radius to the height is always a third, so I take the radius and replace it with h over 3. And then I can simplify from there. Before you take the derivative, you want to try to get the equation into as simple a form as possible. Let's do another related rate, because you guys love related rates so much. Right, Avery? What happened to the pi? Well, I have a pi on the left side. I have a pi on the right side. So I divide 2 by pi. How come what happened to the pi today? Other people got to get it. You didn't. You put chemistry in front of my class. No. All right, let's do another related rate problem. Because we like related rates, don't we? Yeah. Can I give you a really nasty one? Yeah. Okay, a 25-foot long ladder is sliding down a wall at 4 feet per second. How fast is the bottom of the ladder sliding out? When the bottom is 20 feet from the wall. This is a nice, straightforward related rate problem. All right, a 25-foot ladder is sliding down a wall, so we have the wall. We have a ladder. The ladder is 25 feet long. Let's call the distance from the ground, from the bottom of the ladder to the wall, x, and the distance from the top of the ladder to the ground, y. And we know that it is sliding down at 4 feet per second, so dy dt is 4. How fast is the bottom sliding out? We want to find dx dt. By the way, I'm giving you points for setting up and putting down, knowing what you're looking for. I think that's worth at least a point. How fast is the bottom sliding out? So how fast is x changing when x is 20? Okay, do we know a relationship between x and y? We do. X squared plus y squared is 25 squared. Okay. We now take the derivative. We get 2x dx dt. plus 2y y dt equals 0. We can't divide through by 2, make our algebra a little easier. We're trying to find dx dt. We know dy dt. We know x. We only need y. Then we can solve this. So how can we find y? Well, we also know that x squared plus y squared is 25 squared. So we know that 20 squared plus y squared is 25 squared. You do a little Pythag, you realize it's a 3, 4, 5 triangle, so y will come out 15. So now you just plug in. You get 20 dx dt plus 15 times 4 equals 0. And you get dx dt is negative 3 feet per second. That wasn't very hard, was it? Not a hard problem, but if we put that on the exam, a lot of you would mess it up. Guess that. Why do I have to plug which values in? These values in? Oh, here. Well, y is 15 feet when x is 20 feet. Right? Y is 15 feet when x is 20 feet. And we know that y is sliding down in 4 feet per second. Right? By the way, I could have made y negative and x would come out positive. It doesn't really matter. Okay? Let's do another type of word problem. Okay, a corral, as we say out west, consists of 3 rectangular identical pens, as in this picture. So you have 3 holding pens that are the same size, and they share these walls. You have 800 feet of fence. Maximize the area of the corral. Okay? So do you do it? This is not a related rate problem. So one of the things that's going to happen in the final is there will be word problems. There will be optimization problems. There will be related rate problems. Try not to confuse them. It'll be very entertaining when you try to do this as a related rate problem, because the walls are not moving. Okay. So let's see. Why don't we call these vertical walls Y? We call them X if we wanted to. And these horizontal walls X. So the amount of fence that we have is 2x plus 4y, and that has to equal 800 feet. We divide through by 2, so we know x plus 2y has to equal 400 feet. And we want to maximize the area. The area is simply x times y. So now you can take this top equation, isolate one of the variables and plug in the bottom equation. So for example, I could say x is 400 minus 2y. And go over here and say a is 400 minus 2y times y. Or 400y minus 2y squared. Now I take the derivative and set it equal to 0. So a prime is 400 minus 4y. We set it equal to 0, because that's what we do in calculus class. We take derivatives and set them equal to 0. And we get y is 100 feet. X is 400 minus 2 times 100, or x is 200 feet. And therefore the corral, we want to find the maximum area of the corral, would be 100 times 200, or 20,000 square feet. So again, we have 4 vertical pieces, that's 4y, and these 2 horizontal pieces, that's 2x. We know that we have to have a total of 800 feet, so we can say 2x plus 4y is equal to 800, or we will allow for x is 400 minus 2y. Then we take the area equation, which is x times y, and get rid of a variable, take the derivative and set it equal to 0. That'll give us the maximum value of y. The y that gives us the maximum. Now you go back and find x, because x is 400 minus 2y. So once we know y is 100, we know x is 200. And then the area is just 100 times 200. Okay? Alright folks, so we've gotten to the end of another semester. I hope you all have a great Thank you very much. We'll see you at the review session for those of you who show up. And maybe in the spring, and for the rest of you, the night there is almost over.